All right. So, any questions before we get started?
No, sir.
Okay. Here are the notes we're going to cover. And where am I? Business Cal. We are covering 9.4 today. There you go. 9.4 derivatives. Yep. There you go. So those are the notes we're covering. So if nobody has questions, let's get started. This is a long one. Okay. So today we cover derivatives, which is all about slope. Derivative is just a fancy word for slope. So everything today will be about slope, just in different formats. Okay. So the first thing we start off with today is something called the average rate of change. It gives us, this formula gives us the average rate of change from one x value to the next. So the rate of change from x1 to x2 is given by this formula, f of x2 minus f of x1 over x2 minus x1. Now this formula is no different from the one you know already. This can also be related to the original slope formula, y2 minus y1 over x2 minus x1. So there is nothing different. The only thing different here is that this slope formula is in function notation, and this is why we call it the average rate of change. And what it does is helps us find the slope between 2 points on a given function. Okay, so we're going to try that below. It says find the average rate of change when x is 1 and x is 3. Okay, so the way to start this is, of course, label everything. So I'm going to make this x1 and I'm going to make that x2. And now we're going to find the average rate of change. And we're finding the average rate of change on that function above, if I didn't mention it, x squared plus 5x minus 1. So to find the average rate of change on that, well, we just follow the formula above. F of x2, which is going to be f of 3 minus f of x1, which is 1, over x2, which is 3, minus x1, which is 1. So follow the formula, plugging in the components, and now, in order to finish off this average rate of change, we have to figure out what f of 3 is and what f of 1 is. In order to find these values, well, we're going to take 3 and plug it into the original function for every x. And then after we do that, we're going to take 1 and do the same exact thing. So I'll just make a little side work section down here, and I'll say f of 3, and I'm just plugging it into the function above. Gives me 3 squared plus 5 times 3 minus 1. That's going to be 9 plus 15 minus 1. So 24 minus 1, we get 23. And then let's go ahead and find out what f of 1 is. And I'll get 1 squared plus 5 times 1 minus 1. That'll be 6 minus 1, which gives me 5. Okay, so that's what f of 3 is. F of 1 is, we can now continue our average rate of change. And f of 3 we said is 23 minus f of 1 we said is 5 over 3 minus 1, which is 2. Here we get 18 over 2, and we get 9 as our answer. So what we're saying is that the average rate of change from one x value to the next, when x is 1 and x is 3, the average rate of change is 9. So it increases by 9 units. Okay, so graphically, what that looks like, to put a visual on what we just did, just so it doesn't seem like we're crunching numbers, let's go ahead and graph x squared plus 5x minus 1. I'm just going to do a sketch of an x squared function. This is just a sketch, just to show you what's going on. So let's say we start here, and then something like that. So what we found is that if this is x1, and the point related to it is f of x1, and over here is x2, and that point related to x2 is f of x2, then all we have found, I'll zoom in, all we have found is the slope between these 2 points. And that slope, or that average rate of change, happened to be 9. So from x1 to x2, the average rate of change, the slope is 9. That's all we have found. So I'm just putting a visual to our number crunching, just so it doesn't seem that all we do here is crunch numbers. Okay. Everybody good with that one?
Yeah.
Yes, sir.
Okay. Let's keep going then. Number 2, find the average rate of change when x is 1 and x is 1 plus h. So once again, let's just go ahead and label everything. This will be x1, and this will be x2. And let's go ahead again and find the average rate of change. So now we're going to have f of x2, which is going to be f of 1 plus h, minus f of x1, which is 1, over x2 minus x1, which is, I'll put it in parentheses, 1 plus h minus 1. Okay, now we already know what f of 1 is because we figured that above, but now we have to figure out what is f of 1 plus h. So again, in order to figure that out, we're just going to take 1 plus h and plug it in for every x into that original function above. All right, oops, there we go. So if I just said f of 1 plus h, I plug it in for every x above. So I would have 1 plus h squared plus 5 times 1 plus h minus 1. Ugh, the ice cream man's outside. Okay, and now we have a little bit of simplifying to do. So 1 plus h squared means 1 plus h times 1 plus h. Distribute the 5 plus 5h minus 1, and then FOIL the 1 plus h's. You would get 1 plus 2h plus h squared plus 5 plus 5h minus 1. Okay, almost done. Well, we see we have some like terms we can combine. So I have this 1, 5, and negative 1. That's just going to give me 5. And then I have 2h, and 5h. I think that's it there. That's going to give me 7h. And then all that's left over is this h squared. So plus h squared. Okay, so that is what f of 1 plus h is, which means we can now continue to find the average rate of change. So we go ahead and plug in what we just left off with. 5 plus 7h plus h squared minus f of 1. And like I said, we already figured out what f of 1 is. F of 1 is 5. So minus 5 over, and down here, 1 plus h minus 1, well, your 1s are going to cancel and just leave me with h. Okay, I guess I could highlight that, right? This one and that one will cancel. Okay, and then above, this 5, that 5 also cancel. So those are gone. And what we're left with is 7h plus h squared over h. And to finish this off, we notice that we can factor out an h in the numerator. So I take an h out, and I'm left with h plus 7h over h. And these h's cancel, leaving me with the final answer of 7 plus h. This is the slope, or the average rate of change, between those two x values. Now, there's nothing different than what we did above. So number 1 and number 2 are the same process. The only thing more difficult about number 2 is we added some letters in there, right? So to make sense of what those letters actually mean, I'll give you another visual of what we just did. And it's going to be basically the same visual as the above. So here, I'll draw a x squared function. Let me extend that out a bit more though. So just a sketch, right? Not perfect. And here was my x1 value of, and I'm going to put 1. I'm going to say here's 1. And then here was my y value of 5. And then here was my x2 value of 1 plus h, which up here, I'm just going to write f of 1 plus h. So all we have done, again, is found the slope between these 2 points, which happen to be 7 plus h. All right, but all I want you to understand from this is, what does h actually mean here? Well, to understand what h is, all h represents is the distance from one x value to the next. That's it. So h is the distance from one x value to the next. And this is where our limits are going to come in. So whatever value you give for h, this formula will help you find the slope no matter what. So you can pick whatever value you want for h, and that's going to give you that formula will give you the slope no matter what. Okay, which means that when we move on to number 3, this is going to use the answer from number 2. And let me just fix something real fast. I forgot to fix it on here. This should be, what is the limit as h approaches 0, not x. So go ahead and change that to an h. Okay. So this says, what is the limit as h approaches 0 of f of 1 plus h minus f of 1 over h? Well, the great thing about this is we already did that work. F of 1 plus h minus f of 1 is everything we did here which leads us to this answer there. So all we have to do, since we've already done all the work, is just rewrite the limit. And I'm just going to say the limit as h approaches 0 of 7 plus h. Once again, that comes from there. And all we have to do now is plug in what number for h?
0.
0. And we get 7. Okay. So what we're saying with this answer is that, well, if the distance of h is 0, because we're saying let h equal 0, if you reference this lovely graph I made on the right. So if h represents distance and we're saying we want h to be 0, then what you have just found is the slope at exactly 1 point. You have found the slope at exactly 1 point on a function. And what we're used to is finding the slope between 2 points. But if you use calculus and you use limits, all we have to do, or what we can do with all that, is find the slope at exactly 1 point. That's it. And that's going to lead us to the next page, which is called the definition of the derivative. The derivative in calculus will find the slope of a function at any given point, at 1 point, which is pretty awesome. So we don't have to do it at 2 points anymore using the derivative. But any questions on this page before moving on?
So the limit equaling 7, where does that represent on the graph?
So here, okay, so just like I pointed out, so 7 is a slope, right?
Mm-hmm.
Which means that on this graph, this point would have a slope of 7. Just that point.
Oh, because that's the 1 plus h.
Exactly. So remember that this slope is represented by 7 plus h. But what happens if h is 0? We're right back at this point, which means, again, we have found the slope at exactly 1 point.
Okay.
There you go. All right. I'll say slope at x equals 1. So 7 is a slope when x is 1. All right. Pretty crazy. All right. Which means let's go ahead and get into the definition of the derivative. So for y equals f of x, we define the derivative of f of x denoted as f prime of x. So just to go over some quick notations and how to read them. F prime of x means a derivative, and the way we say it is the way I just said it. F prime of x. So f prime of x means the derivative. And the formula for the derivative is given as f prime of x equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now, this formula may look familiar to you. Does anybody know the name of this formula? You've seen it before. F of x plus h minus f of x over h is called the difference quotient function. You guys remember that?
No.
No, kind of. You should have seen it in your last class, but if you didn't, well, now you're seeing it now, right? So remember that in algebra, you practice the difference quotient to practice your algebra skills. So what we're going to do now is, well, when you did the difference quotient, your main mission was to get rid of that h. And that's still our goal. But now, after you get rid of that h, we are now going to apply calculus to it. And the only calculus we are applying to the difference quotient function is this limit notation. So after you simplify everything and get rid of the h in the denominator, the last step you are going to do is plug in what number for h?
0.
0. That's it. Look at that. So, but we have a lot of simplifying because if you remember these problems, it's a lot of algebra and it's very easy to make a mistake. So the derivative will find the slope of a function at any given point. And now we have to just truck through all that algebra to find the derivative. So for this next example, it says find the derivative of f of x and then find f prime of 1. So what we're going to do is find the derivative, and then for the next one, we're going to plug 1 into the derivative. But that's when we get there for the second part. So for number 1, let me zoom in because I'm going to need the space. Let's go ahead and find the derivative of this function. And if you ever find the derivative or ever work a difference quotient, the very first step is to always plug in x plus h. So this is the first step. And for your homework, it's going to ask you for the 4-step process. So we're going to make this a 4-step process type of example. Okay, so here's the first step. Plug in f of x plus h. So you're going to plug in x plus h for every x into this given function and simplify. So we're going to get f of x plus h, 4 times x plus h minus x plus h squared plus 5. So we have plugged in x plus h for every x, and now we must simplify. So go ahead and distribute that 4. You get 4x plus 4h minus, and now we have some work to do. X plus h squared means x plus h times x plus h plus 5. And we have to FOIL out x plus h times x plus h. All right. So when you FOIL this out, so that negative's still there, x plus h times x plus h is always going to FOIL to x squared plus 2hx plus h squared. So to save you guys some time, if you ever see x plus h squared, just know that it will always FOIL to x squared plus 2hx plus h squared. That'll save you a lot of time on these really long problems. Okay, now we have to keep going and distribute that negative. 4x plus 4h minus x squared minus 2hx minus h squared plus 5. And on the first step, 99.9% of the time, there are no like terms ever, which means this step is done. And as ugly as it looks, that's all we can do. There is no terms we can combine here. Okay. And that would be your first answer for your homework. Then the next step. Zoom out a bit. There we go. Now we move on to step B. The next part is, what is f of x plus h minus f of x? Lots of writing here today. So we already know what f of x plus h is. We figured that out above, so I'm going to rewrite it. 4x plus 4h minus x squared minus 2hx minus h squared plus 5. And now this minus f of x part means we are going to subtract the original function that was given above. So I'll go ahead and write that in there. Minus, and When you subtract the original function, do not forget to put it in parentheses. If you don't put it in parentheses, you're going to have terms that don't cancel out, and you're going to be left with a bigger mess than what you started with. So make sure you put the original function in parentheses, because this negative has to distribute to all three terms. Okay, and unfortunately, rewrite everything again. Minus 4x plus x squared minus 5. And after you distribute that negative, here's the rewarding part out of all of this. Terms will cancel. Now look at this line and tell me which terms are going to cancel.
4x and minus 4x.
Good.
5 and negative 5.
5 and negative 5. Good. One
X
more.
squares.
X squared, negative squared. Yeah.
There you go. No, that feels great, right? Now, all we're left with is 4h minus 2hx minus h squared. And this will be the answer you put in my math lab, because my math lab says do not factor anything out. Just give the answer like this. So I'll put MML answer, right? But the way I like to finish off the second step is always factor out an h. If you factor out an h, it's going to make the third step a lot faster. So I'm just going to factor out an h first, and I'll get 4 minus 2x minus h. Okay. That was step B. Woohoo, look at that. We're moving. Now on to step C, or the third step. We want to know, what is f of x plus h minus f of x all over h? And now we plug in what we left off with in step 2. H times 4 minus 2x minus h all over h. And now you see why I factor that h out in the beginning, is because this h and that h will what?
Cancel.
Cancel. And we're left with 4 minus 2x minus h. Look how nice that was. That's shaved off like a second, right? And that's your answer for step 3. And now we get to the final step. Oof. Step D. This says, what is the limit as h approaches 0 of f of x plus h minus f of x all over h? And all we do is start where we left off with in step 3, or step C, and I'll rewrite this as the limit as h approaches 0 of 4 minus 2x minus h. And here's the next rewarding part of all this. What number do you get to plug in for h?
0.
0. And we get our final answer of 4 minus 2x. Woo! This is the derivative. All right. So you see all that algebra involved? Very easy to make a mistake. And you don't want to make a mistake when you have a bunch of work. Okay. And then another way to rewrite our answer is we will say f prime of x, which is the derivative, equals 4 minus 2x. There it is. And now there's one more step. It says find f prime of 1. So all that says is take 1 and plug it into the derivative. That's it. F prime of 1 gives me 4 minus 2 times 1, which gives me 4 minus 2, which gives me 2. So what this is saying is that when x is exactly 1, the slope will be 2 for this original function. Crazy, I know. Okay. Any questions on that process? You're like, I'm still trying to write step B down.
And that's for what point? For point 1?
Wait, say that again.
Is the slope for...
So what we're saying with this answer on the right is that when x is 1, the slope is 2. Yeah. Keep talking about that. Nice. Okay. All right. Well, let's keep going. We have one more derivative. Well, we have a lot more derivative problems, but these are just straight up derivatives. Okay. So let's do it again. F of x equals 7 plus 5 over x. Let's run through all those steps again. Here we go. Turbo time. A, what is f of x plus h? And you'll get 7 plus 5 over x plus h. And that's it. That's all we can do for step A. Nothing else. Step B. What is f of x plus h minus the original function f of x? Okay, well, we know what the original function is. So, I mean, we know what the original function is, but we know what f of x plus h is. So we're just going to bring down what we found above, 5 over x plus h. I don't need parentheses there anymore. I'm using the wrong color. Oh, no, sorry. There we go. 7 plus 5 over x plus h minus, and now we subtract the original function, put it in parentheses, and I have 7 plus 5 over x. Okay. Now distribute that negative, and we get 7 plus 5 over x plus h minus 7 minus 5 over x. All right. Well, something nice is about to happen because we see that our 7s will cancel. Gone, gone. And I'm going to make a lot of space for this one. I'll say equals, and I'll write this out here just for space. Okay. So now here's what we left with in step 2, which means we're not done with step 2. We have to combine these two fractions. And if you ever want to combine two fractions by addition or subtraction, you need what type of denominator?
The same one.
A common denominator. Yes. And just to let you know, these denominators have nothing in common. Nothing at all. Yes, there's an x here. Yes, there's an x there, but they are not the same denominator. So for these types of problems, what you're going to do is take this fraction and multiply it by the denominator of the left fraction. So we're going to multiply this by x plus h over x plus h. And then the same could be said for the other fraction. This fraction on the left is going to get multiplied by that denominator of x. So we're going to multiply this by x over x. Okay. And now what we have is 5x minus 5 times x plus h over my new denominator of x times x plus h. So all I did was combine these numerators on the next step because they have the same denominator. Okay. Now, just to go over a don't, right? Let's say don't do this, right? So you saw it was 5 over x plus h minus 5 over x. And you're like, okay, so you thought there's an x here, there's an x here. All this denominator needs is an h. So if you were thinking just to multiply this by h over h, it's a good thought, but it's the wrong thought because once you multiply it, you are going to end up with 5 over x plus h minus 5h over xh. And tell me, is x plus h the same as xh?
No.
Not at all. So don't make that mistake, guys, because that'll ruin all this work you have to do. Okay. So now we keep moving. We're going to simplify the numerator. And you're going to distribute that 5. So 5x minus 5x minus 5h over x times x plus h. And now, a little bit of relief here. Your 5x's cancel, and we're left with the final step, or the final answer of step 2. Negative 5h over x times x plus h. There you go. That ends step 2. Whew, man, which means on to step 3. So, C. F of x plus h minus f of x all over h. Well, we're going to rewrite what we left off with. Negative 5h over x times x plus h. And we're going to put it all over h. And since we're doing all this complicated work, I'll allow you to do one little cheat code here. We're going to say that this h and this h will what?
Cancel.
Cancel. Oh, yeah. And all we're left with is negative 5 over x times x plus h. And that ends step 3. Woo! All right. Now on to step 4. Let's get this derivative. So D. The limit as h approaches 0 of f of x plus h minus f of x all over h is going to become the limit as h approaches 0 of negative 5 over x times x plus h. And once again, the most rewarding part, you get to plug 0 in for h. So if you do that, what is my final answer? That'll be x times x plus 0, which will give me what?
X squared.
That's it. There's your derivative. Oof. Okay, perfect. And then to finish this off, let's write it as f prime of x equals -5 over x squared. There's the derivative. And now all we have to do is plug in 1. So f prime of 1 equals -5 over 1 squared, which is just going to be -5. So what we can say for this function is that when x is 1, the slope is -5. That's it. When x is 1, the slope is -5. Okay. So those are derivatives, and it is an algebraic, definitely an algebraic process. Very easy to make a mistake. So watch all your steps, watch all your signs, watch all your multiplication. Okay. Any questions on this page?
I'm good.
Like, we're all good, man. Don't worry. What's today? Wednesday? Monday's lesson is going to be real rewarding. We're going to do these a lot faster.
Oh, that's good.
Yeah. But for now, we have to get through the long process only in order to understand the shorter process. Okay. Let's keep going then. All right. So this page talks about the tangent line and the slope of the tangent line. So first off, what does it mean to be a tangent line? And if you look at this lovely picture below, a tangent line is a line that shares a point with the graph. So we share this point here. It shares one point and only one point with the graph and takes off. That's it. This is what it means to be a tangent line. You come in, you share a point, and you take off. So our goal for the next problems is to find the slope at exactly this point. And then after we find the slope, we're going to have to find the equation of a tangent line. So this is going to bring back a lot of skills that you have used already. If you remember the review, you guys were making the equation of a line. And in order to make an equation of a line, you need a slope and you need a point. So this is going to be one big exercise on that, involving the derivative as well. Because if we want to find the slope at exactly 1 point, this means we're going to have to find the derivative of the given function. Okay. And it just so happens that the slope of the graph at any point, x and f of x, is given by this formula. The slope of the tangent line is equal to the limit as h approaches 0 of f of x plus h minus f of x over h, which happens to be the derivative. Oh my goodness, right? So look at all those connections. So if you find the derivative, you're also finding the slope of the tangent line at any given point. It's crazy. Okay. So let's go ahead and get started below. So find the slope of a tangent line. The slope of a line tangent to the graph of f at any point x, f of x on the graph is given that we saw from above that the slope of the tangent line is equal to the derivative. And here is the function we are given, x squared plus x. So our first step is find the derivative of this given function. All right. Oh boy, we just did it twice. Now we're going to do it 3 times. So remember those steps, guys. So let's get through this. Let's go ahead and find out what f of x plus h is. And we're plugging him into this function over here on the right. So x plus h squared plus x plus h. And like I said, I showed you a shortcut. So what does x plus h squared FOIL out to?
x squared 2hx h squared.
There you go. X squared plus 2hx plus h squared plus x plus h. Okay, perfect. Actually, I'm going to move this over a bit. Let me see if I don't mess anything up. Because we can shortcut a couple things now that we know this process. Because now, since we finished this process, all right, stop moving, stop moving. There we go. Oh boy. Yeah, that didn't do what I wanted. It didn't cover everything I picked. Okay. You will get everything I selected. How's that? Did it do it? It sure did. Okay. So now I move that over there. And now that is the end of step A, which can bring us into step B. Watch this. I'm just going to put B right on the next line. Going to save us a lot of time. F of x plus h minus f of x. And we're going to subtract the original function right over here. Minus x squared plus x. And then just do that since we saved a little time. Rewrite that. Rewrite that. Distribute that negative. And now, after you distribute that negative, what terms are going to cancel?
X squared and x.
X squared and x. Gone, 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 gone. Okay. And now what we're left with is 2hx plus h squared plus h. And then we're going to factor out an h. H times 2x plus h plus 1. All right, so that's going to end step 2 for us. So I cut the process down by like maybe a step, which means we move on to the next step. Actually, let's just go ahead and kill this already. We're just going to make this our final step. We're just going to say the limit as h approaches 0 of f of x plus h minus f of x all over h. And this is going to give us the limit as h approaches 0 of what we just left off with, h times 2x plus h plus 1 all over h. And just like all the ones before, the h's cancel. And we're left with the limit as h approaches 0 of 2x plus h plus 1, where now you plug in 0 for that h, and we get the derivative at 2x plus 1. There it is. There's our derivative. And once again, you can write the answer as f prime of x equals 2x plus 1. Okay, excellent. So there's the derivative, nothing different. We've done it 3 times already today. That was the 3rd time, which means we can move on to the next step. Step 2, find the slope of the tangent line to the graph of f at x equals 2. So all this says is take this value of 2, plug it into your derivative. Oh, such an easy step, right? So we'll have f prime of 2 equal to 2 times 2 plus 1, and we get 5. This is the slope at x equals 2. Okay. And now this says graph the original function and sketch the tangent line at x equals 2. Okay. Oh boy. So this is the long one, because now you guys have to remember how to graph a quadratic function. Because this problem, what I'm working, is like a problem exactly in your homework. So let's go ahead and just start by rewriting the original function down below. And when you're graphing this function in MyMathLab, it's going to ask you to find the vertex. It's going to ask you to plot the vertex. Does anybody remember the formula for the vertex? No? Okay. It's negative b over 2a and f of negative b over 2a. So remember that this functions in the form of ax squared plus bx plus c. So when I find the vertex, my x value, I get negative b over 2a, and my b value here from this original function is going to be 1. So I'll get negative 1 over 2 times my a value, which is also 1. And we get this x value is at negative 1/2. But since we're in business math, I'm going to make that negative 0.5. And then to find the y value of your vertex, well, just take 0.5 and plug it into the function. So you're going to get negative 0.5 squared plus negative 0.5. And that would be 1/2 squared, which is 1/4. 1/4 plus 1/2, I think, gives me negative 0.25. Let's just verify that. Yep, negative 0.25. So this means that our vertex is at the point negative 0.5 and negative 0.25. Okay. And now, one more thing in order to plot this function. So again, once you're plotting this quadratic function in MyMathLab, it's going to ask you for the vertex, and then it's going to ask you to choose another point to graph this function. So in order to do that, well, let's just take a peek at the original function again, x squared plus x, and set it equal to 0. And what I notice is that I can factor out an x, and this will give me x times x plus 1, which means that this is going to give me 2 answers for x. I'm going to get x equals 0 and x equals negative 1, which these are 2 points we can now choose to plot. These give me my x-intercepts at 0, 0 and negative 1, 0. I just put it below. All right. So that was just a flashback on how to graph a quadratic function. Oh boy. And then now we're going to plot that. So I'll put the graph here. Hey, look at that. That's pretty. Okay. And I'm at negative 0.5 and negative 0.25. Well, it doesn't have to be too perfect. So let me see. Here's going to be negative 0.5 and then negative 1. And then if I'm at 0.25, here's negative 0.5 and negative 1. So my vertex is going to be right here at negative 0.5 and 0.25. There we go. There's my vertex. And then I'm just going to pick one more point. I'm just going to choose that point 0, 0. And once you pick 2 points that are on the quadratic function, MyMathLab will graph it for you automatically. So it's going to graph you something like this. Okay, and now we have to get back to the calculus because this now says sketch in the tangent line at x equals 2. So based on my graph, here's 0.5, here's 1, and then here's 2. So if we go up, we're looking at this point exactly. So if you want to find this point exactly, just go ahead and take 2 and plug it into the original function. So I'll say find the point. When x is 2, we get that f of 2 is going to be 2 squared plus 2, which will give me 4 plus 2, which gives me 6. So the point is going to be 2, 6. Okay, so whenever you're graphing the tangent line in MyMathLab, it's going to say pick 2 points on the line. Well, 1 point you know already is 2, 6. And then if you want to find the second point, well, just use the slope of that line. The slope of this line happens to be 5. So all you would do in slope terms is you will go down 5 units and over 1 unit. So I would go down 5 units. Let's just say this. I'll put these here. So here's 6. There's 6. If I made this correctly, there's 5, 4, 3, 2, 1. So what I would do is go down 5 units. So let me change color. 1, 2, 3, 4, 5, and I would move over 1. And that would give me another point. So basically, our tangent line is going to look something, well, actually, it wouldn't be on there. It would probably be around here. It's going to look something like this. And that's it. This is our tangent line. Oh boy, and that's all you would have to do for that problem. Doesn't seem too intense, right? Oh man, we lost a lot of people. Oh yeah, for this one, I would say plot using point and slope. Remember, our slope was 5. Okay. All right. Well, I'll keep going. This is the very last question, example 4. So we get an application to all of this. So this says the revenue in dollars from the sale of X infant car seats is given by R of X equals 24X minus 0.010X squared. Find the average change in revenue if production is changed from 800 car seats to 850 car seats. Find the derivative, and then we'll move on to step C once we get through all that. So this one is using everything we've learned today. So this wants to find the average rate of change in revenue if we produce 800 car seats and 850 car seats. So again, just label everything. This will be X1. This will be X2. So if I'm finding the average rate of change, and my function is revenue, so I'm just going to rewrite this as R of X2 minus R of X1 over x2 minus x1. And now, since I labeled it all, we get r of 850 minus r of 800 over 850 minus 800. And now a little bit of side work down below. Let's go ahead and figure out what r of 850 is and r of 800 is, which means you just plug these into the revenue function given above. And I'll just use my calculator for that.
Do you have
Let's
to
see.
put the R variable on the top?
Like here?
No, the next one.
Oh, this one. Yeah, you want to do it there because it's saying it's like the average rate of change, r of x2 minus r of x1. If you just put 850, you're not going to know to plug it into the function.
Okay.
Okay, so I'm just plugging these in. So let's see. I'm better off doing this. 24x minus 0.01 x squared. And if I type in 850, I'll get 13,175. And if I type in 800, I'll get 12,800. So I get 13,175 minus 12,800 over 50. And 13,175 minus 12,800 is 375. So this will give me 375 over 50, which is 7.5. So what we're saying from this answer is that if we produce 800 car seats to 850 car seats, revenue is going to increase by $7.5. That's it. So I'll put here revenue increases. Okay. So that's the average rate of change. We did that on the first page. And now we get to the derivative. Oh boy. So this is going to be our fourth time doing the derivative today. So our first step is we're going to say, what is r of x plus h? And I'll get 24 times x plus h minus 0.01. I don't need that extra zero there. Times x plus h squared. Distribute everything out. 24x plus 24h minus 0.01 times x squared plus 2hx plus h squared. Distribute that 0.01. And you'd have negative 0.01x squared minus 0.02hx minus 0.01h squared. Okay. And then, like I said, let's shortcut some of these. We're going to slip in r of x plus h minus the original function. So here, I'll plug in the original function, 24x minus 0.01x squared. And to save some time, I'm just going to distribute, no, I have time. I have 24x plus 24h minus 0.01x squared, 0.02hx, 0.01h squared, minus 24x plus 0.01x squared. Okay. And always in step 2, we have terms that cancel. 24s are gone and x squareds are gone. So gone, 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 gone. And I'm left with 24h minus 0.02hx minus 0.01h squared. Factor in h out. And we get 24 minus 0.02x minus 0.01h. I think I have all that. Good. Yeah. And now we move on to step C, which will squeeze everything in here. We're just going to say the limit as h approaches 0 of r of x plus h minus r of x all over h. And we're going to have what we left off with, h times 24 minus 0.02x minus 0.01h all over h. I forgot my limit in there. It's okay. We'll bring it in on the next one. The limit as h approaches 0, because these h's cancel, of 24 minus 0.02x minus 0.01h. And we get the derivative, oh my goodness, so long, of 24 minus 0.02x. There we go. This is r prime of x. Okay. So that was the 4th time doing the derivative, which means we can move on to step C, because all step C wants us to do is take 800 and plug it into the derivative. So it says find the revenue and the instantaneous rate of change of revenue at a production level of 800 car seats. Oh, this wants us to plug 800 into the derivative and the original function and interpret the results. So for this one, I would just say r prime of 800, and you would get 24 minus 0.02 times 800. And if I do that, 24 minus 0.02 times 800 gives me $8. And then if we did R of 800, which we did above already, R of 800 is $12,800. So it says find the revenue and the instantaneous rate of change of revenue at a production level of 800 car seats and write an interpretation of these results. Okay, so what this says is that, well, what the derivative says, since it's positive, and remember derivative means slope, what this says is that since we get a positive $8, revenue increases at 800 car seats. And the 12,800 is the revenue at 800 car seats. So this is the revenue at 800 car seats. And that is it. Brutal.